Welcome, everyone. Today, we are going deep into the world of mobile security, specifically focusing on GSM security. While we use 4G and 5G today, GSM was the foundation of everything. We're going to look at the architecture, the secret codes, and the reasons why older 2G networks are sometimes vulnerable to hackers. Let's get started. The main goal of GSM was to make your mobile phone as safe as a landline at home. To do this, it focuses on three big things. Anonymity. The network tries to hide who you are from anyone sniffing the airwaves. Authentication. This is like a digital ID check. The network needs to be 100% sure that you are a paying subscriber before letting you make a call. Confidentiality. This is the scrambling part. It ensures that if someone intercepts your signal, all they hear is digital noise instead of your private conversation. To understand security, you have to know the team working behind the scenes. That's your phone and SIM. This is the radio side, the physical towers, BTS, and the controllers, BSC, that manage them. This is the brain. It contains the MSC, which routes your calls, and the HLR, which is a giant database of every user. This is like a temporary guest list for users who are currently in a specific area. This is the security guard. It creates the secret triplets RAND, SRES, and KC we use for safety. This is the blacklist. It tracks IMEI numbers. If you report your phone stolen, the EIR blocks it, so no one else can use it on the network. Your SIM card is much more than a storage chip. It's a tiny, secure computer. It holds your IMSI, which is your global ID number. Most importantly, it holds the key, which is your 128-bit secret key. Extra detail. The key is never sent over the air. It stays inside the SIM. The SIM does all the math internally, using algorithms called A3 and A8. This is a brilliant security feature, because even if a hacker intercepts your radio signal, they never see your master key. Think of this as a secret handshake. Instead of you sending your password to the network sends a random number called RAND to you. Your SIM takes that RAND, mixes it with your secret key using the A3 algorithm, and creates a result called SRES. You send the SRES back. Because the network also knows your key, it does the same math. If your numbers match, the network knows you have the real SIM card without you ever having to tell them your secret key.
At the exact same time the handshake is happening, your SIM runs a second formula called A8. This creates the KC, or ciphering key. While SRES was just a yes-no check to let you on the network, the KC is the actual key used to scramble your voice. Extra detail, this key is 64 bits long and is sent to the cell tower so the tower can lock and unlock your voice data. Now we get to the actual scrambling, which is the A5 algorithm. There are different versions. A50, this means no encryption. It's like talking over a loudspeaker. A51, this is the standard version used in most of the world. A52, this was a weakened version made for export. It was eventually broken and is now banned because it's too easy to hack. A53, this is the modern strong version based on the Kasumi algorithm, which is also used in 3G networks. For those of you into the technical side, A51 uses something called linear feedback shift registers, or LFSRs. It uses 3 of them. They move at different speeds based on majority logic. Think of it like a clock where the gears turn in a complex pattern to create a stream of random-looking bits. This stream is XORed with your voice. Every single frame of your call uses a different frame number, which means the encryption is constantly changing, making it very hard to crack in real time. Nothing is perfect. The biggest flaw in GSM is unidirectional authentication. This means you prove yourself to the tower, but the tower doesn't prove itself to you. Hackers use this to build fake towers, IMSI catchers, that trick your phone into connecting to them. Also, encryption only exists between the phone and the tower. Inside the network cables, the core network, your data might be unencrypted. Plus, if someone physically steals your SIM and has the right tools, they can clone it. To wrap up, GSM was a huge leap forward, but it relied on security by obscurity. meaning they hoped no one would figure out the math. Modern 4G and 5G have fixed these holes by adding mutual authentication, where the tower also proves it's real, and much longer 256-bit keys. The big takeaway: treat your SIM card like a credit card, keep it physically safe. And remember, while 2G is old, its lessons shaped the secure mobile world we use today.